Okay, so first let's use decision trees. And again, I encourage you to, jump out to here and just if you want to refresh yourself on decision trees. Again, we're not getting into the details right now of how these things work. Most of you should have seen decision trees in my class or the data science class already. So sometimes the challenge is you just got to figure out, well, what's the what's the library that I need to import from sklearn, and it's not too difficult. A little googling, if you Google sklearn decision tree, you'll find this quickly. Or just looking in the user guide. So let's import that. So now we're going to do our kind of 4 steps. We're going to instantiate a new model, fit it, and then we're going to score the fit. And also, the decision tree is going to get initialized with one parameter set, and that's going to be this min samples split guy, and the default value is 20. So what this is saying is that, hey, every node in our decision tree has to have at least 20 samples in it to be allowed to even be considered for splitting into, to 2 branches and 2 new nodes. So if once a node has less than 20 samples, then it becomes a terminal node in the tree. Okay, so I'm going to create my decision tree classifier, and the only thing we're doing is setting this parameter of min sample split. Then we'll go ahead and we'll call its fit method, and we pass in the X matrix and the Y features and target, and then we can use the score method after the model's been fit. We just give it X and Y, and it'll tell us how we did. All right, so let's see how we did. Ah, brilliant. So we've got just over 82% accuracy on the training data. Remember, that's the training data. So don't get too excited when you get great fits. And of course, if you get super, super, super high fits with training data, then you should start to worry about, and I'll let you think on that. We'll come to that in a second. And since this is our kind of first time using scikit-learn in the class, we're going to use the predict method. We always do a fit and then a predict on our new data. But let's predict both the classes. That uses the predict function, or the predict method, if you want to think of it that way, and also the probabilities themselves, not just which class. In this, there's a built-in method called predict underscore proba, just to see what they look like. So you'll notice here, the first one, we're going to predict the class. So if we were forcing sklearn and say, hey, you tell us which class I should do, this is the ones that it's going to pick. So I'm going to call the predict method on our tree object, and I'm going to do it on the test data. Okay, so now we're actually trying out our model. And notice what I'm going to do. I'm going to store the predictions back here. So it's probably just going to be an array. And then I'm going to slice it, and we'll just take the first 5 elements, see what it looks like. Okay. Great. So it predicts that the first row is a whatever species 51 is. That's what it predicts. 6, 14. Those are the predictions. Likewise, now you can also do the probabilities, and so I'll call predict prob A. I'm gonna slightly slice the matrix differently this time, just so we can see a little bit more, just so you can kind of interpret these a little bit. So I'm going to get the first 3 rows and the first 15 columns. All right, so if you take a look at these, all right, and you can see that bracket matches up with that bracket, and that bracket will match up with that one. So in this third row, right, so this is really what we're looking at in the third row. In fact, all these are zeros because the first class, if you notice, we predicted 51, and then in the second row, actually, yeah, let's look at the second row. The second row, we predicted 6. And if you actually look at the second row, right, here it is, right? 0, 1, 2, 3, 4, 5, 6. It actually predicts a probability of 1 that that leaf is type 6, whatever tree type 6 is. Now for this one, for the third row, okay, so let's notice 0, 1. So it gives a 42% probability that it's type 1. And then I've only printed out 15, so we know that that guy is 14, and a 47% probability that it's 14. So if you forced it to choose, hey, you need to classify as either this type or this type, it's going to pick the larger number. So since 0.47 is bigger than that, it will classify it as a 14, and that's why that guy got classified as a 14. Okay, so no rocket science. So now I'm going to write this thing out for a submission to Kaggle. And notice I'm storing all my output files in this output folder. Okay, so I'm going to go now and let's go take a look at that. Oops. Go back to my images. All right, so here's my output folder. And we can see, what did we just do? We just did a tree. All right, and I'm doing this on April 30th, so literally, right there it is. So these are slightly older. And if we want to see what these look like, I could open it in Excel. I could open it up in Notepad++. So it's just a big giant column of the the columns and then one row with the probabilities in them. And with all Kaggle competitions, you have to go to the Kaggle site and see what it wants in terms of the format for the Kaggle competition, in terms of the submissions. So, quick digression. Sometimes it's really nice to be able to visualize things like matrices and trees. It can help you understand how techniques work. And so you'll often see this in tutorials. So like a really simple thing is I could make a color map of the probability matrix. And so there's actually a built-in method called match show, kind of like show matrix. And I'm just showing, whatever, 200 rows and 100 columns. And I'm using a certain color map called blues. And so you can, darker blues are higher probabilities. So kind of in an ideal world, right, we would just have, one dark blue per row. Anywhere we have, kind of the medium color blue, we've got, a harder time figuring out what species it is.